Hello and welcome back to the Land Rover Toolbox videos. You'll probably remember, if you've been following us along, that I did a little bit about welding a bracket on an axle. Now we're going to go into depth with welding techniques because obviously Land Rover maintenance, repair and overhaul requires us to rectify the horrors that we find on these aging vehicles. Obviously the chassis, especially on the rear end, this is Discoveries as well, obviously suffer quite badly from the old tin worm. Now you've seen in most of our series we've covered some sort of maintenance or just a discovery of certain crimes that people tried to hide. Like this bulkhead here was fiberglass, and it wasn't actually too evident until we stuck a pen in this project bulkhead here that it was also fillered. Now these sort of things obviously need rectifying, and the only way you can do this on steel is welding. Okay, there's a big thanks to Arkwright Welding and Safety Limited, who have supplied us a welder so we can carry on with these tutorials. These are the guys that also supply Corollas paints. Now the welding equipment that we're using is varied, but we shall be using a power weld welder, which is their mainstay in their supplies. So first of all, you can take yourself a walk around anywhere and look at the examples of welding that you'll see on almost everything that is made of steel. Now there's some good welds, some good production welds, and then there's some not so good welds. If welding, first of all, is alien to you, then just walk around and have a look at some objects, see what sort of welding has been done on the objects that you can see. Obviously, there is more than one material. This material is aluminium, so it would have been Tig welded. And the welding comes in varying qualities. There's also production welding done by machines. As you can see, the seam on here is not hand welded. Also, if you look on your axle ends, the flanges have been friction welded together onto the tube. Okay, so those of you who have been following us for quite a while, we had a wooden workbench in the workshop. It's now been removed and we have half a chassis here which we're going to practice on. Basically, the chassis has been sitting in my front garden for at least a year and a half, and it won't fit in the workshop, and I really need to get it under cover, so I've cut it on a straight piece, which will give us the opportunity to later sleeve it and weld it back together. If you're curious, which I'm sure you are, what the condition of the chassis is like inside, and this is a galvanised one, you can see that it is in not a bad condition at all. There's actually no corrosion in there. Basically, I've set it up so it would be almost like you're working on your drive on the back end, which means we're going to have some compromising or welding positions to work at. The other half of the chassis is still in the front garden, plus we also have the D2, which failed on a rotten chassis on the back end, so we're going to have to weld this up as well. In the workshop manuals, or some of them, you'll actually see some workshop equipment that you can make up. I've got some steel cut by the engineers, and we will be eventually making equipment as well. Hopefully I can keep my promises on this one. Right, so the chassis is fairly good condition. However, I will be fitting a few things on, showing you how to weld them on correctly. Basically, what we need to ascertain first is what exactly do you need to weld. Now, depending on what you need to weld is what type of equipment you need to purchase or use. So basically what we need to discuss is the pros and cons of certain equipment. Okay, so what I have here is manual metal arc welding equipment, or a stick welder if you like, and it's the first type of welding that ever came into existence. The manual metal arc, obviously you have amp settings and you use an electrode which has got a coating on it. You have an earth and a positive obviously, and a power supply, and this is regulated so you get the right amperage to do welding depending on what thickness of metal you're going to weld. Now the thing with the manual metal arc, it can weld a variety of different metals, which are stainless steel, casts, alloyed metals, and obviously your mild steels. The electrodes themselves, they have their own flux coating. Now you see on this example here that I'm striking an arc with it, which takes a little bit of skill, but once it's started welding, it will weld through paint and rust and quite a lot of the dirt, so the slag takes a lot of the impurities out. Whilst you're welding, you also need to shield the medium so it doesn't oxidize while it's being fused and fusing the metals together. Using a stick welder, you can penetrate or get a better penetration on your welds than you can with a metal inert gas welder or a Mig welder or a full automatic welder if you like. The bonuses of stick welding are quite incredible, to be honest with you. You can weld with quite a few different mediums. Okay, so the other option we have is a Mig welder or a Mig Flux Core welder. In this case, it's actually a Flux Core welder. Basically, it's fully automatic. It has a drum of wire. You run the wire through a set of rollers. You then can hold your torch at the same distance away from your workpiece. Now, there are some benefits to Mig welding because it's quicker. You can get the job done quicker. However, with Mig welding, you need an inert gas to shield the metal so it doesn't oxidize, and this can be a problem in winds or if you run out of gas. Now, with the Flux Core, it has, like a stick weld, it actually has the flux with it, which means you don't need to use gas. Okay, so I'll do a little summary here. Manumetal arc basically has a wide variety of rods which you can get for different thicknesses of metal, different types of metal, and of course in different situations such as even underwater you can manumetal arc in deep sea situations. Not that we're going to be doing that, of course. Whereas the Mig welder, obviously you need gas with it and it has a lot more moving parts to it. However, it is quicker and it's easier to use, easier to set up, and basically it's better for the beginner. You'll find that thinner metals can be welded easier with Mig welding. However, it has a trouble penetrating thicker metals. I'll just add another one to the pot here, which is the most interesting, which is Tig welding or Tig welding, which can do all of the metals in various positions and also welds aluminium. What we've got to remember here, the Tig welder can be turned into a Mig welder, however you need to manually feed the wire in to weld. Okay, so now I'm going to leave you with thinking about what sort of material you want to weld. If it's mainly thin stuff, you'll want something like Flux Core or a small Mig welder. If it's something heavier like a chassis, then you'll be considering something like a manumetal arc welder.